pollutants can be defined as substances which causes harm to the humans and the environment. Air pollutants can be solids, liquids, or gases, and it can have devastating effects locally, regionally, as well as globally. And when there's a high concentration of that substance, it causes air pollution. This week, we're going to talk about how these air pollutants causes what we know as acid rain. Acid rain is when precipitation is below the pH level of 5, and it occurs when the deposition from the atmosphere contains a high amount of nitric and sulfuric acid. Rain is naturally slightly acidic with a pH level of about 5.6. This is because it is dissolved in the carbon dioxide found in the atmosphere, creating carbonic acid. Volcanoes and decaying vegetations are also some natural sources which make rain slightly acidic. However, due to the burning of fossil fuels and industrialized activities, huge amount of pollutants such as carbon dioxide, sulfur dioxide, and nitrogen oxides are emitted when fossil fuels are burned. The sulfur dioxide then reacts with water, oxygen, and other chemicals in the atmosphere to produce sulfuric acid that results in acid rain. Cars and trucks emit a lot of harmful byproducts such as sulfur dioxide, carbon monoxide, and nitrogen oxides during fuel combustion. After nitrogen oxides are released into the air, it reacts with more oxygen and dissolves in the rainwater to form nitric acid. The presence of both these acids made the rain's pH level go up as high as the pH level of 3, and that's 1,000 times more acidic and dangerous compared to normal rainwater. There are natural alkalis and bases present in the environment that can neutralize acid rain. Some examples include ammonia, which is a base released as a result of agriculture and human activity, and some areas with alkaline soils and rocks, such as limestone. Since carbonate is a type of alkaline, the large supply of carbonate ions in ocean waters is also able to neutralize acid rain. However, when acid rain lands on neutral or acidic soil, it is in fact very harmful for the environment. This is especially true with places with thin soil and granite bedrock, since they are unable to neutralize the acid. In acidic conditions, vegetation is greatly damaged because the enzymes that are vital for growth are unable to function, so they aren't able to carry out photosynthesis. Moreover, acid rain encourages the leaching of nutrients and dissolves toxic metals such as aluminum in soil sediments, which then poisons the plants and animals and harming our ecosystem. The high acidity in lakes and rivers corrodes the fish's organic gill material and attacks their skeletons, which results in a huge decrease in the biodiversity and the population of the fishes. The nitrogen now present in the rivers and lakes then flow into the ocean waters and increases algae bloom, which then depletes the amount of oxygen present in the ocean waters. Sulfur dioxide particles in the air causes visibility impairment as well as dry cough, eyes, throat irritation, asthma, as well as other respiratory diseases. It can also erode buildings and statues made of limestone and marbles, as well as increase the corrosion rate of metals. I think we can all agree that acid rain does horrible things. So, as the people who created the problem of acid rain, we have tried to solve that problem. A way that's being used to reduce the effects of acid rain is by adding limestone, also known as calcium carbonate, into the rivers and lakes to neutralize the acid. This increases the pH level of the lake as well as encourages the return of salmon. However, this might be harmful to some organisms within the lake and can do more harm than good. Another way that's being used to reduce the effects of acid rain is hydrodesulfurization, which takes place in oil refineries. Hydrodesulfurization takes place in a high temperature, and sulfur is removed from the crude oil to produce hydrogen sulfide. This then refines the oil, and when the oil is used, less sulfur will be emitted into the air. In utility plants, catalytic reductions are used to convert nitrogen oxides into diatomic nitrogen. Ammonia will be injected into the reaction chamber, and that gas will react with nitrogen dioxide and oxygen to produce water and harmless nitrogen molecules. Since most of the nitrogen oxide is being released through cars, catalytic converters have to be installed in them to convert the nitrogen oxide back into nitrogen and oxygen to reduce its emissions. To reduce the effects of acid rain, many power stations uses fuel gas desulfurization, and that's just a fancy way of saying removing sulfur-containing gases. During this process, sulfur dioxide is being neutralized with scrubbers made of limestone, and that produces calcium sulfide as well as carbon dioxide gas, and all the waste product is then later disposed of. All these methods that I just talked about help to prevent sulfur dioxide and nitrogen oxides from getting emitted into the atmosphere, and that reduces the emissions by 90%. It provides country with cleaner air, however, it reduces the efficiency of the power plant stations by about 10%. If you're wondering, oh gee, acid rain can only be solved by these big fancy chemical equations and there's nothing I can do to help, then you're wrong. Because there are many things you can do to help solve acid rain. First of all, you can help by saving energy and turning off appliances when you're not using them. Second of all, you can take public transportation and walk or carpool whenever it's possible. And lastly, you can choose to use clean energy resources such as solar power and wind power. So there are obviously many ways in which you can help. Acid rain can greatly damage our environment and our ecosystem. If all the forests are destroyed and all the lakes are polluted, then that will mean the animals will have no food and no shelter. And when that happens, that will lead to us having no food source. Even though air pollution is a bigger problem in urban areas, it can also accumulate in suburban and rural areas as well. Some air pollutants such as erupting volcanoes and decaying vegetations are all examples of natural air pollutants. Some examples of unnatural air pollutants are sulfur dioxide and nitrogen oxide, which we cause. So we should find solutions to these problems and preserve our home, planet Earth. Thank you for watching yet another depressing episode on how chemistry can cause problems to the environment in Shannon Logic. I'll see you next week with another depressing episode, so stay tuned.